Good afternoon, everyone, and thank you for joining us. My name's Andre Kearns. I'm Marketing Director for our AWS Aerospace and Satellite business segment. Now, we have a lot that we want to share with you in this session, so why don't we jump right in. Here's the agenda that we're going to cover in this session. First, what I'd like to do is set some market context on the unique challenges associated with achieving land, sea, and space domain awareness. Then I'll introduce how AWS and our partners have worked to meet this challenge through the creation of Project Argus. Then I'll ask leaders from AWS Partners, BlackSky and Ursa Space Systems to introduce themselves and their companies. Then we'll move into a fireside chat. And we'll close answering your questions. And just as a reminder, we are recording this session, and it should be posted to YouTube within a week or so. All right. With the proliferation of satellites into low Earth orbit, space traffic management has become a key challenge. And so you see commercial and government entities really struggling to get a full, transparent view of the space environment and also associated risks. And this is driven by a number of challenges. One is lack of access to a single source of domain data. Another is an inability to quickly and easily analyze and visualize all of this data. And then third is really the cost associated with collecting, analyzing, and visualizing all this data. So as a result, our customers really are inhibited from achieving that ability to view past events from a domain awareness perspective, and then to be able to model future conditions that'll allow them to really identify, understand, and ultimately, as required, mitigate risks associated with space traffic management. Solving big challenges like this is why we created AWS Aerospace and Satellite. So AWS Aerospace and Satellite helps our customers to reimagine their space systems, to really automate their data workflows, and accelerate innovation, and most importantly, to meet their challenges and successfully deliver on their space missions. And so we deliver solutions that really help to reduce and eliminate the barrier to space, whether it's issues around latency or low network bandwidth or data infrastructure. And so, for example, AWS has created Argus in collaboration with many of our partners, including BlackSky and Ursa Space Systems, in order to increase our customers' accessibility to decision-ready information to allow them to achieve land, sea, and space domain awareness. A little bit more about Argus. So Argus leverages the AWS cloud and also our AWS partner network, including BlackSky and Ursa, to really help our customers to collect, analyze, and visualize both Earth observation data as well as space observation data, and really use all of that information to understand, again, past events and to model future conditions. And so Argus delivers that decision-ready information that our customers need and that they can apply to a range of use cases, from space traffic management to space domain awareness to maritime domain awareness to geospatial intelligence. So now I'd like to introduce our presenters. So I'd like to introduce Dr. Peter Wagner, who's Chief Technology Officer at BlackSky, and Nicole Robinson, who's President of Ursa. So I'd like to invite each of them to come and introduce themselves and their companies, and then we'll start our fireside chat. So Peter, over to you.
Well, Andre, you for the invitation to be here, and thank you for all of you for being here. I'm really excited to talk about what we do at Black Sky. Black Sky is a global intelligence company. And the way we provide this global intelligence to our customers is we start with the world's highest revisit rate commercial satellite constellation. We have satellites on orbit that are flying over our heads today, right now. We cover about any spot on the planet 15 times a day from dawn to dusk. And those satellites collect high-resolution imagery, feed that down to the ground on very short timelines. I'll show you some examples of that. And then fuse all of that with open source data that we pull from all over the world. Think of things like news media feeds, social media feeds, earthquake reports, weather reports, any kind of data that can be geolocated to a spot on the planet and overlaid with this near real-time image of change of what's happening on the planet. We feed all of that to our customers and provide them insight into what's happening in events that they care about or sites that they care about. So let's take a look at what that actually looks like as an example. This is a video, I think it'll start here in a sec, of...
One more time.
One more time. There we go. This is a video of us monitoring one of the largest Amazon air hubs in northern Kentucky. So you see in that little short video, over the course of a 30-day period, we were able to monitor this airfield from space. We can give our customers ideas of what's the earliest time of arrival of aircraft, the latest time, the patterns of life of aircraft moving in and out of that particular area. And a lot of this is done with automated analytics, artificial intelligence algorithms that are pulling the aircraft out of those scenes, categorizing the aircraft and telling our customers when the aircraft are coming, what type of aircraft are they. Now, if you apply that to a number of additional use cases, your mind maybe can really expand on the potential applications. Obviously, border security issues, national security. We can talk a lot about what's happening in Ukraine and how satellite systems are providing the whole world really insight into what's happening in that part of the world. You can think about supply chain management, port monitoring, watching ships coming in and out of ports, moving commodities around the world. You can think about trains moving those kind of commodities from the origins of mines into the ports where they're distributed around the world. Or you can imagine using these kind of tools to provide crisis response in natural disasters or sometimes man-made disasters around the world. This is all what Black Sky does today. Here's an example of taking those tools and applying them to a really significant problem for the world, which is monitoring the activity of Russians around the Ukrainian nuclear sites. You can see in this example, we're pulling in news media feeds and social media feeds at the bottom, pulling all the critical information out of that. When the system sees people in military uniforms, it alerts us that they're in that region. We fly overhead with our satellites, take high-resolution imagery, and we can stack all of this data together to get real deep insight into what's happening in maybe a critical event that the whole world's going to care about. Crisis response. We're using the same tools to monitor the flow of refugees out of Ukraine. This is monitoring one of the ports, and you can see the buildup of cars and buses at this port throughout a 24-hour period from early in the morning to late at night. All of these tools are really built on top of this big data lake. All of this is built upon the Amazon cloud, where we do all of our data storage and processing. We build all of our algorithms there, run these machine vision algorithms on top of that deep stack of imagery, and we're pulling out in real time the kind of information that our customers are really going to care about. So just to wrap up, this is really Black Sky. We're a global intelligence business. Today we're delivering about 2,000 images a day around the world to our customers, integrating all of this on the Amazon cloud, pulling all these other open source data feeds in and exposing all of that deep stack of intelligence to customers who really need to know what's happening right now today. Thank you.
That's great. Thanks so much, Peter, and Andre as well. I'm Nicole Robinson. I'm the president of Ursa Space Systems. Really interesting to hear these two esteemed colleagues talk about the value that Argus has provided and their individual organizations as well. For Ursa, when we were created about 8 years ago, it was during a time that there was a tremendous amount of development happening from a design, build, and launch perspective for synthetic aperture radar or SAR satellites, optical satellites, AIS, even RF mapping. We'll get into some of those over the course of the session today. During that time, there also seemed to be a bit of a gap in terms of, okay, we're going to have all this data, we're going to have all this imagery. What are we going to do with it? How are we going to bring it together? How are we going to produce an insight that is actionable and useful and can empower the kind of results our customers are looking for? So that's where Ursa Space was founded. Our specialization is really in data analytics and data orchestration. So today we work with a host of different providers across those different sensor types I mentioned. We bring the data into our platform, and in an automated fashion, we're able to produce change detection results, what has happened in a particular location and how that changes over a series of time. Layering that with the fused results of multiple sensors simultaneously gives that added geolocation accuracy, added intelligence feature, and really takes satellite and geospatial intelligence to the next level. So excitingly, we've been part of the AWS Partner Network, and as part of that network, we've been able to participate in the Argus exercise here. A large part of that was about the bringing together of all of those disparate geospatial organizations and capabilities that I referenced to produce a dashboard that delivers insights, what was happening along the area of where the anti-satellite launch activity took place last November. So really exciting to have been able to take that call to action and join with the colleagues here on the stage as well as many others. In terms of how that plays into the way that we typically operate at Ursa Space, since we are processing all of that data across the different modalities, we're bringing it into our platform, and we have those analytics that are producing the results, it's a tremendous storage requirement. Today, we've got about 16 million images stored based on all the collections that we have in our archive to date. So having the AWS cloud is really an incredible capability to be able to really carry that heavy load. Additionally, to be useful in producing our analytics to our customers, we have to be quick. An insight as to what's changing in a certain location is critical now. Receiving it in 3 days, perhaps it's not as useful to see what's changed given the mission at hand. So in that instance, in partnership with AWS, we do take advantage of leveraging the EC2 as well to be able to deliver more rapidly to our customers those critical insights. What I wanted to share with you as well is a video here to kind of highlight some of the features of our platform and the way that it works behind the scenes to give a little bit of color as to how it connected with the Argus project. So as you can see here, that platform really is useful in terms of being able to source and bring in data over a particular area or object of interest. In the case of Project Argus, our participation was really about collecting a time series change detection report to show activity over the 6 weeks prior to the launch on November 15th. In doing that, we were able to identify, here are a host of different changes that were happening in and around the launch pad area, and perhaps learn how we can model that behavior in more of a predictive fashion going forward, taking from that the lessons learned to apply to understanding how we might be able to identify and potentially thwart such an activity in the future. So the solution that we put forward really combines the satellite imagery, the space data, and also all source data as well in order to indicate the events that have happened, predict what may likely happen next, and provide indications when future risks to space operations and sustainability may occur. In this particular exercise here, our platform was able to download and store on the order of 87,000 low-resolution images and 10 million SAR images on the AWS cloud between the period of January 2021 and November of 2021. So really to give that background and historical perspective of what had transpired. The change detection algorithms that we used were processed through an Amazon EC2 instance for imagery between that period of time to really give this interesting indication. During the time of that anti-satellite launch event, the area over Russia actually experienced pretty significant cloud coverage. And that's material when you think about the different types of data sources that can come into a solution like this. In the case of optical imagery, which really gives you, as you were seeing from Peter, that pristine bird's overview to give a sense of what's actually happening with a degree of high resolution. When there's cloud coverage, you don't always have that opportunity. The strength of synthetic aperture radar, or SAR, is that it can see through the clouds, it can see through smoke, and it can see anytime, day or night. So really powerful capability there to help give that foundational level of what had transpired in and around the region. The dashboard that you're seeing here shows multiple data sources overlaid on a map, 1 billion mobile devices, mobile device interactions were taking place from 21 million unique devices and movements over that 6-week period of time. And you can see that all shown here simultaneously with the SAR change detection data at several cosmodrome sites in Russia. So this yielded 2.5 million changes over the span of those 6 weeks. Clearly something that a degree of automation and having those analytics into the platform is particularly important to be able to produce those results. Those results, by the way, once we ran it through the system, were produced in just about 24 hours. The speed to turn around that kind of capability is once again something that is beautifully enabled in the partnership between Ursa Space and AWS. So if we look here and we kind of zoom into the Plesetsk Cosmodrome area where the change resulted in a number of different detections here, you can see objects that are new to the scene are appearing in green. Those are the green indications on here. Areas where changes have decreased are in red. We often call that red has fled, just as a way to pick up the change in the depiction on the dashboard. And the blue and yellow dots are concentrations of where mobile device activities were detected. So changing to more of a historical overhead base map view, which you're seeing here, you can see more of a concentration of mobile device activity in the main buildings of Complex 41. The green area here near the top, it's a significant change detection that warranted a closer look, as there may have been new building taking place in and around that particular complex in the couple of months prior to November 15th. So indicating activity, indicating plans for activity to take place. Zooming out a little bit, we can see in the bottom left of the screen here, all of Russia, where the devices that had been active in the 6-week prior, from September through the November timeframe, those devices we were able to go back and locate had been as far east as the Kamchatka Peninsula and as far west as the Ukrainian border. So as a reminder, these mobile devices were also seen in the Plesetsk Cosmodrome as well. Some of these locations, including the more rural areas, were good candidates for deeper analysis, and we provide that to our customers so they can do that study. Ursa has that capability of that deeper analytics. We leverage our higher resolution synthetic aperture radar as well to determine which vehicle types were in those regions, support that with the high resolution optical imagery as well to make a depiction of the vehicles that were in that region as well, and provide that enhanced intelligence. Really looking forward to the Q&A portion of this session here. Argus was just an incredible exercise of bringing the industry together, really a 1 + 1 + 1 = 100 scenario, and really reflecting all of that high impact data into a common usable dashboard. So looking forward to that. Thank you so much for your time.
All right, now for the fun part, the really fun part. Thank you both for those amazing introductions. So let's jump right in. So it seems like both Black Sky and Ursa are both contributing important geospatial capabilities, right? Which, once combined, create that synergy that allows customers to achieve cross-domain awareness. And you all mentioned lots of different data sources: Earth observation data, SAR data, mobile data, open source data, AIS data, et cetera. So how is this trend toward multi-data, multi-sensor data fusion helping organizations to achieve land, sea, and space domain awareness to drive decision making? Nicole, why don't we start with you?
Yeah, oh, I love the question. Before joining the geospatial industry 2 years ago, I actually spent 14 years in the satellite communications part of space and satellite. We actually saw a very similar trend, and it was really a shift away from raw data, raw capability, into more usable connectivity or insights. In the case of the SATCOM community, it was the advent of high throughput satellites. So gone were the days of just lighting up megahertz and transponders, and now entered the times where a managed network, an end-to-end solution was the expected solution. So there, I liken it to customers no longer wanting to buy wheat, but wanting to buy bread. We're seeing something very similar happen in the geospatial arena as well, where they're moving away from that raw data, raw pixels, and instead wanting that full analytic insight.
Peter?
No, I think Nicole is absolutely right. I think we're just at the very beginning of this. I think the way I generally think about this is sort of the way we as humans sense the world around us. We have our sense of taste and touch and smell and sight and hearing, and we combine all of those different senses together, and that gives us this deep insight into maybe what is a threat or what is an opportunity for us. And I think remote sensing is very much the same way. Each of these layers of information gives us deeper and deeper insight into what might be a threat or what might be an opportunity. So I think as the world builds out the next 5G network, with they're projecting to have 8 billion connected devices on, that's just a broad sensor network. And we're going to combine that sensor network with the sensor data we get from remote sensing satellites and all the other data feeds. And we're just going to get deeper and deeper insight into those threats and opportunities.
Thank you. Those are really helpful analogies, right? To take some of these concepts that are highly technical and just make them real, right? The whole notion that a hungry person needs bread, not raw wheat, right? So you need to make the bread, you need to deliver the solution to enable decision makers and not deliver a bunch of raw data, right? And then in your instance, all these different data modalities represent the different senses. And we need all of our senses to really synthesize and understand the world. So thank you for that. Now let's dive a little deeper into how each of you are supporting Argus and how you're using the cloud with AWS to do so. So Peter, let's start with you on that one.
Yeah. I mentioned just in passing in my comments earlier that when we started Black Sky, we started as a cloud-first business. We realized early on that leveraging the power of the AWS cloud for all of our data storage, all of our machine learning development and algorithm exploitation, but also satellite design and operations. The whole company is built on really the power of that cloud environment. And it really is an enabler. I've often said to people that I think in my life I've seen 3 enablers that have made companies like Black Sky and Ursa and all these things possible. One is the cost of launch coming down. 2 is the cost of the satellites themselves coming down. But number 3 is actually the cost of the data center and managing that massive amount of data. When I started in this business, I would say just a few years ago, but I'd be lying. Long time ago, we built every satellite, we built a dedicated data center for it. And that sometimes cost as much as the satellite to build. So it really is one of the amazing enablers that I think has made this whole industry possible.
Thanks. Yeah, absolutely, right. A fundamental value proposition of the cloud is this pay-as-you-go model to drive down your cost of operation and cost of innovation. So thanks for that. Nicole, your thoughts?
Yeah, I mean, Ursa's contribution to to Argus was really about processing the data rapidly, and that really requires a degree of automation. I mean, as we were showing in some of the material earlier, we processed 80,000 SAR images in a matter of just a couple of days. So to be able to do that, I think in partnership with AWS, what we learned was the importance of automation and the importance of speed. So leveraging AWS storage, we're able to have millions of our imagery and data sources available on AWS Cloud, and leveraging AWS Ground also helps us to accelerate the speed to deliver. So it's really a wonderful opportunity to participate in Argus specifically. The mission is so important. The learning and the application of that learning is so important. But for us as a company, it also helped us to really double click on the need for that automation, the need for that speed, and really refine what we were doing as a result.
Well said. Another couple of great kind of value proposition points on the cloud, the ability to automate those data workflows and that undifferentiated heavy lifting, and also the scale that the cloud provides. We're talking massive amounts of data, and so the cloud provides that natural environment to be able to have all that data in one place, fuse it together, and then bring your analytics and apply it to drive decision making. So, great. So let me go back to you, Nicole, on this one, because you touched on this in your introduction around the ASAT example that you shared. But how does geospatial intelligence in the terrestrial domain connect to and intersect with intelligence in the space domain?
Yeah, I think there's definitely a convergence happening, a powerful convergence, a multi-domain convergence. If we think about, a couple of examples, the preeminent way of delivering intelligence, surveillance, and reconnaissance type information was from drones historically. Well, these are quite expensive platforms. Not only the platforms themselves, but the cost to maintain them, to operate them. Sure, they're unmanned, but there's actually a crew that's responsible for their activity and the delivery of that data. There's a huge SATCOM pipe related, and there's a cost related to that and a management to that. So taking the combined capability of, in this example, drone-based or remotely piloted aircraft data feed, layering that with satellite-based ISR, game changer. If we think in the maritime sense, there are really incredible platforms out there that are able to identify, here's a particular area for maritime surveillance that we want to traverse. And they'll run a number of caps on a daily basis to be able to do that. Being able to bring in that satellite intelligence, it's a cost saver, it's an operational enhancement of the capability, and it really, the convergence of those two spaces, the two domains, is powerful. And I think that's not the distant future, but tomorrow.
Yeah, pretty much happening now.
Yeah.
Absolutely. Peter, your thoughts?
Well, I think this is another area where we are just at the very beginning of this convergence of the terrestrial economic zone and the celestial economic zone, and being able to understand how each of those different domains impact and influence the other. As an example, we're seeing now a lot of movement to start connecting cell phones directly to satellite. And now space is starting to really connect with the multi-trillion-dollar communications market that has traditionally really been, I don't want to discount the SATCOM part of that, but has primarily been a terrestrial economic zone. Now it's really moving to space. And in the future, we're going to want to understand, how does that satellite that's moving over maybe from this spot to this spot, or a new constellation being launched, how does that connect with that terrestrial network? And what is the economic impact of all that? What is the national security impact of all that? So connecting that intelligence, understanding what's happening in that terrestrial domain with what's happening in that celestial domain is really going to be important to understanding our world in the future.
Wonderful. I think one of the things that triggered as you were talking for me was, we're talking about some pretty amazing innovation that we're driving today. But to your point, we really are at the beginning stages of this. How we're connecting space observation data, Earth observation data, land, sea, and space domain data, and connecting that, we're really just at the beginning stages of the innovation that can drive for us in the future. So, inspiring stuff. All right, next up, I'll lead Peter with you on this. So how is Argus better than free space information that anyone here can get today from websites like spacetrack.org?
Yeah, I think that's just to touch on what I was trying to bring out a minute ago, is that if you look in spacetrack.org, you get to see a TLE. Here's an object number. Here's its TLE, here's where it's going to be in orbit at any one time. But it doesn't really tell you who owns that satellite. If it's maneuvering, why is it maneuvering? What's happening on the ground at maybe the command center or with the company that owns that satellite to cause it to take these actions, or even anticipating those moves. And being able to really understand the space domain at that level is going to be really important. Not at just the blob level, not at just, I can get a TLE and project the orbit over time, but really deeply understanding, what is that satellite? Why is it moving? Who owns it? How long is it going to operate? Is it operating now? That's deep insight, deep intelligence that we're really going to need to know to understand that domain.
That's great. So it kind of goes back to your senses analogy, right? Like, this is one source.
That's right.
That may deliver one sense, but you really need to pull in those other data sources and that fusion to get the full value and have all your senses as you're working to understand things.
Absolutely.
Yeah. Nicole, your thoughts?
I love that. I love the summary that you just applied there. It's nothing wrong with the free data being provided. That's wonderful. We'd like to address as many new users of geospatial as we can, and that's a nice hook to be able to do that. But it isn't the data, it's what you do with it, So as you're talking about the multi-int, kind of bringing all those different data sources together, and the production of an analytic, the production of an insight, something that's actionable to respond to, that's the real power of geospatial. So I love that you both reflected on that as well.
Fantastic. Let's stay on this topic of multi-data integration for a little while longer. So let's say we have interested Argus customers, and they're interested in integrating their own proprietary data into what's available through Argus. So can they do that, and how can they do that? So Nicole, do you want to take that?
Yeah, I think that the power of Argus is really bi-directional from that perspective, where the data sets in Argus are fully downloadable so that they can be ingested into a customer's platform and another node into what could be a broader ecosystem of insight and intelligence that they're working with. The other way around is also interesting. I know, for Ursa Space in particular, we have this concept of BYOD, bring your own data. And we have some customers who may want to feed unique sources of data stream, and they want to look at that as a layer on top of some of the geospatial components that we have ingested into our platform. So I think that's really important for Argus to really have the full value that it can bring to customers, is to provide that two-way, the fully downloadable data sets, and then also the opportunity to bring national or other data sets into the fold so that it can be layered.
Right, thank you. Peter?
Yeah, not a lot to add. I think Nicole said it very well. I mean, that AWS Marketplace concept that you can bring your data in here, it's exposed, people can see it, you can mine it. And then on the other end, having insight into here are the tools that are available in that marketplace to integrate that data and maybe run some analytics on it, whether it's a SAR data stream or an EO data stream. As I said in my comments, the Black Sky Spectra platform, we can take just about any kind of data that you can geolocate. And if you can geolocate it, now we can start correlating that data together. So yeah, I think the more data, the better, so bring it on.
So you can bring your proprietary data, make sure it's geolocated.
That's right. Well, or we could help you with that too, maybe. I don't know.
There you go. Excellent, excellent. Great, well, we've covered a lot around sourcing data, and Argus helps to offer that one source of domain data, right? Now let's talk about analyzing and visualizing that data to discern insights. So what are some of the trends in big data analytics and machine learning that you all are most excited to see coming about as the benefits of Earth imaging and all of this data capture becomes more and more accessible to organizations outside of the government and defense spaces? So, Nicole?
Yeah, I think trend one I see is really pointing back to that pixels to insight, that wheat to the bread analogy. And one of the learnings that we had over the course of this year at Ursa was through the experience in the supporting the conflict intelligence scenario in eastern Ukraine. And in that scenario, in the first couple of weeks of the conflict, the customer was asking for raw data. They needed access to the full SAR. I mean, at that point, the first 6 weeks of the conflict, there was only 6 days without cloud. So it was heavy on the radar component. Synthetic aperture radar was the way to understand what was going on in areas of interest. They were asking for this data that if you've seen a SAR image before, it doesn't look like the beautiful pictures that Peter shared. It's a radar black and white image. So actually the worst thing that we've done is calling SAR an image, because you have this expectation it'll look a certain way. To an untrained eye, it's not going to tell you very much. In addition, sending those very high data files across, even in an S3 bucket, to the customers were burdensome. They're downloading it, they're trying to see it in the field. So we quickly evolved to this place where they said, okay, run your change detection analytic on it, and instead take a screenshot of the report. Send that to us. So it says, this roadway has damage in these locations, perhaps don't evacuate in that direction. Or this energy tower is experiencing this kind of impact. Or these vehicles or potential vehicles are in this particular area. That then became very actionable information they could make decisions on really rapidly. So away from pixels to the insights is trend number one. And trend number two, which we've really brought up in the context of Argus here, is from single sensor to multi-sensor. From taking one source of data and layering additional sources of data, increasing your geolocation accuracy, increasing your intelligence of what's transpiring in a location. Love those two trends, and I think it's high impact for our customers.
It's pretty powerful. You're right. If we just put a SAR image in front of most people, they wouldn't know what to make of it. And the fact that Ursa is able to kind of, through the application of analytics, turn that into insight, right? Be able to see change, identify objects and classify objects is just absolutely amazing. So thanks for that. Peter?
The only thing I would add, I think Nicole said it beautifully, the only thing I would add is that what you asked what makes me excited about, it's the speed at which it's being done. Not so many years ago, if you wanted to get a SAR image or an EO image from space, you would wait days, maybe weeks to get that. And what we see is that the earlier you can understand the scope of an event or maybe a natural disaster, the earlier you can get that insight, the more effective you can be in your response with sometimes less and less energy applied. And I think it's really, that's the thing that excites me, is that we really as a community have an opportunity to make a really fundamental difference in a lot of people's lives just by the speed at which we're able to operate that system together.
Wonderful. Yeah, I mean, if you think about a lot of the Earth observation capabilities that are growing, you hear a lot about improving resolution, right? What you can see in the image. But you're also talking about that temporal resolution. Capturing a site or an area of interest more frequently so that to a finer level of detail, you can understand the changes and the activities and understand exactly what's going on there.
That really pristine image 3 days later may not be that useful.
Right.
But getting that image in an hour, now that might really save someone's life.
I think that's a great transition to my next question. I would say historically you have these Earth observation providers that have, for the most part, been known to enable wide area mapping and creation of maps that are somewhat static until you're able to get more collections and update. But as I said at the top of the presentation, we're seeing this proliferation of satellites in low Earth orbit that's creating all this amazing additional collection capability, right? And so I think there's now this new era of site-specific monitoring that's enabled by that. And I think that's emerging in the geospatial community. So can you just talk a little bit more about that and your thoughts? Peter, I'll start with you.
Yeah, no, absolutely. I think you're absolutely right. Historically, remote sensing from space was about creating high-resolution maps. And that's very important.
Change it, like update once a year?
Yeah, maybe once a year or once every quarter or something. And that's very important, and it's still very important. But this is different. This is a new era of real-time intelligence. What is happening, on the other side of the world an hour ago? And that's a capability that's really never existed in the commercial world before. And it is opening all these new kind of opportunities that we talked about, from understanding defense and intelligence problems to supply chain issues to natural disaster response. Really, it's amazing. It is going to change the world in a profound way, I think.
Wonderful. Nicole?
Yeah, and I think from wide area monitoring perspective to site specific, some of the trends that we're seeing here, I mean, I think geospatial is really the Swiss Army knife of intelligence tools in that way. We have, different customers, different requirements. There's a different tool for a different job. So from one perspective, we have a host of customers who do come in with more of a persistent monitoring, wide area monitoring requirement. And others have a unique object or a set of objects that they've already identified. They want to ping them and track them over a period of time. Both are really important. So in the case of a maritime use case, you may be staring persistently over a particular body of water looking for vessel activity. So then you go from that wide area monitoring to vessel detection. Then you'll move into vessel classification. Well, what kind? Is this a fishing boat? What is this particular vessel? And then you go into tracking. What's the behavior of this vessel over time? So there is that Swiss Army knife of tools where, just depending on what you're looking to do, is it activity just moving in and out of a port? Or if it is the tracking, the identification, the classification, that's much more site and object specific. So really exciting time to see a lot of those different features come together. And again, coming back to the kind of the multi-int or the multiple sensor fusion aspect of it, in Peter's opening video there, showing that incredible aircraft tracking tool to say, okay, from 10 a.m. to 5 p.m., here's the kind of traffic patterns that we're seeing. We launched this week, Ursa Space launched this week, an API for automated aircraft detection. And it's 24/7 to be able to stare at a particular airfield and detect movement. Imagine layering that on top of Spectra with the Black Sky optical-based aircraft detection. Just incredible capabilities there, but that's certainly much more site-specific than the wide area monitoring.
Yeah. And your comments also speak to the importance of the analytics component in all of this, right? To go from wide area mapping down to more site-specific monitoring, you need to be able to detect the change and reduce the area down to exactly what you want to be monitoring. So that's powerful. And it's just amazing to think that you're going from really good maps that are somewhat static now to really having the capabilities to deliver living maps that are really good and they're current. Because to your point, it may be a great map, but if it's a week old, it's not particularly useful for me. But if it's current, it's much more useful. All right, so next up, why or when is space-based Earth imaging a good option compared to, let's say, traditional airborne intelligence gathering such as drones or aircraft? Nicole, I'll start with you.
Yeah, I can think of a specific use case. For the insurance community, for example, wildfire detection. Most insurance companies are leveraging fixed-wing aircraft. So as the wildfire is presenting the damage that it is, they're deploying fixed-wing aircraft over the area to take video. They then have to come back, download that video. They have to produce it in such a format that it can be useful to the claims adjusters and those who are looking at it from that perspective. Meanwhile, SAR is always on. It can see through smoke. It can see through, day and night. It keeps folks out of harm's way. It takes the burden of having to store and operate and manage the data from a fixed-wing aircraft and instead puts eyes in the sky that's able to produce that insight within minutes instead of days. So I think there's a time for airborne ISR, of course, and there's so many use cases where that's the enhanced way to go. But I think if we contemplate where geospatial intelligence can really augment some of those use cases, like for insurance and wildfire detection, we can buy smarter and we can help save lives. We can help inform those who are in harm's way much more rapidly.
Great, Peter.
Well, the benefit of going to space, obviously, is that there are no boundaries. There are no national boundaries. There are no overflight restrictions. You can fly over the whole planet. Mm-hmm. And that's really powerful. As Nicole said, there are trades. The benefit of being able to park a predator over a spot on the planet is you get 24/7 staring, persistent, super high resolution imagery. But there are a lot of places in the world you can't put that kind of aircraft. And the other thing, there is an interesting trade that goes on. It actually turns out that when you look at the life cycle cost of a satellite versus an airborne asset, the cost curves are oppositely loaded. In other words, the cost of this satellite to get on orbit is really high up front, but the operational life cycle cost is pretty low once it's on orbit. The annual maintenance to just keep it there is almost zero. I wouldn't say zero, but almost. The cost of airborne ISR systems is the opposite. Much lower cost to start, but over time as the system ages, the annual operating cost gets higher and higher and higher. And so you integrate those cost curves over their life cycle. In many, many, many applications, it's going to be much cheaper to go to space to do that job than it is going to be to do that job with an airborne system.
Right.
Now, there are trades. We got to learn, how do you deal with the fact that satellite's not hanging over that spot? You don't have 24/7 staring persistent. So what is the sampling rate you really need to understand that target? And can you get that kind of sampling rate from space? If so, then I think you're going to find it's a very efficient solution.
I think it's well said. And it's also amazing to think, even though the cost to get to space is high up front, that's coming down.
It is coming down. Yeah, it is coming down a lot. Yeah,
absolutely.
Those three cost drivers I talked about earlier, all three of those are coming down dramatically.
Terrific. Well, I have two questions left, so let me ask this one. So what are the use cases for Argus that you all see emerging across land, sea, and land, sea, and space domain awareness? I think you mentioned use cases. So let's start with you, Nicole.
Yeah, I think Argus was such a powerful tool, not only to show geospatial capabilities and reflecting on what has happened in the past, But more importantly, how do we take those lessons and provide a training tool, an automated training tool that can help predict what may happen in the future? That's really what I think we've learned from Argus to be applied to other use cases. Maybe a commercial use case, since Argus is more intelligence related, given what had happened there, more of a disaster situation. In a commercial scenario, predictive insights could be for commercial shipping, the movement of goods, tracking the movement of goods in and around a given area. If we take, for example, some major goods that are indicating supply chain, so global oil supply, we're staring at 20,000 locations on any given week, about 4 billion barrels of capability, and producing insights for our customers as to what's happening with the supply, the crude oil supply globally on a weekly basis. And in doing that, it gives the commercial shipping companies an indication of, okay, where's the demand coming from? How do we plan our routes a couple of weeks in advance to be best positioned for that? Similarly, they take that data set and they layer it with our traffic reports. We stare at the 26 busiest ports in the world and indicate where there may be high levels of traffic at any given port. So again, commercial shippers can say, how do we navigate, how do we do route optimization to avoid this idle time at port, costly from a fuel perspective and a schedule perspective? Keep in mind that oil supply view, and then layer maybe a third data set of global auto manufacturing. Who's likely to be moving the most amount of vehicles over a span of time? And using these insights, commercial maritime organizations, commercial shipping organizations, they spend a little with geospatial to save a ton in all of those other aspects of route optimization. So Argus, I think, is a really powerful way of indicating that for intelligence purposes, certainly very many other use cases to be applied. I just wanted to say one more thing too about the power of AWS and all of that. Peter and I have both talked about storage capability, about the ground infrastructure, the speed that's enabled. One thing we didn't talk about that I'm really glad that Andre's on the stage here and facilitated this is the megaphone that you uniquely have provided, Andre, and the marketing organization of AWS, the spotlight you've put on geospatial and those powerful use cases that we provide. So certainly hats off to you, and really appreciate everything that you and your team have done to feature geospatial in such a material way to touch so many lives.
Thank you so much. Really appreciate that. Yeah, we're telling amazing stories, and we firmly believe that the global space industry runs best on AWS, and I think these are great examples of realizing that. But I also want to say, your example around how Argus can enable the connected supply chain, I thought was really fascinating, and it's got to be a solution that many organizations are looking for now, given some of the supply chain challenges that we're all facing coming out of COVID. So fascinating stuff. Peter, what are the emerging use cases from your perspective?
Well, I think the supply chain use is critical. Who in the audience hasn't had some supply chain issue disrupt their personal life this year? If anybody raises their hand, I'd be shocked if you did not. So I think that's very important, and I think that global view that you get from space really gives you that perspective to understand those things, those supply chains on a global perspective. But the one use case that I'm really excited to see evolve over the coming years is really that understanding of intelligence terrestrially with celestially. As we think about in a decade, maybe 20,000 more satellites launched, maybe that's a conservative number actually, and the connection of telecom networks from ground to space and remote sensing and maybe in-space manufacturing and in-space tourism, then understanding economic intelligence in that celestial, in the space domain, connecting that with economic intelligence in the ground. I think that's a really exciting market opportunity that's facing all of us in the next decade.
Absolutely. Wonderful. Thanks for that. And I'm going to ask myself the last question. And it's the question that I think is on all of your minds. This has been a great session, so how do I get started on Argus? So AWS and our Argus focused partners have worked to provide our customers access to Argus in as easy and flexible way as possible. And so we have invited our Argus partners to list their Argus capabilities on the AWS Marketplace and also the AWS Data Exchange. And so we're really excited to be able to say that you can access Argus and it's as easy as a click of a button. And so we're excited to be able to deliver that that space, land and sea domain awareness to our customers as easy as clicking a button. So let me close out by thanking both of you for participating in this session and providing your insights, and thanking all of you in the audience for joining us. And so I hope you found this session helpful. And so with that, I'll close things out, and we'll close with the Q&A with our final minutes. And so I'd like to point out that we do have a mic right here. And so if you do have a question for our presenters, feel free to step up to the mic and ask away. Any questions?
We'll make it a lightning round.
Hello. So could I combine data from satellite imagery to ground soil conditions? So I want to look at soil conditions for farming. Can I do that?
So you're combining
I want to combine
soil
data,
condition data with Earth observation satellite
correct.
data?
I want to find out the capability of farming land through satellite imagery and soil conditions.
We would love to help you with that.
Yeah.
I'll leave you with a card afterwards.
Sure.
Soil moisture is another area where SAR is particularly well positioned to be able to indicate the level of moisture in soil, which is, has economic, agricultural, a whole host of different indicators. But interesting that you bring up defense as, that's an important indication. What's the status of the soil, and what might that mean for what can traverse or what has maybe taken place in a certain region? So yeah, would love to talk to you about some SAR-based options for that.
Thank you.
Hi. So this question isn't directly about Argus, but you mentioned that in the next couple of years there'll be like 20,000 more satellites going into the air or into space, and I assume that number only increases over time, right? And I'm wondering, is there any kind of effort in that industry to make sure that we don't lose the night sky? Is there any conversation around that?
More of a space domain awareness kind of
question.
Yeah. So you're asking about the proliferation of satellites in orbit and whether it'll impact the night sky? Yeah. That's a great question. I don't know the answer. I would say that the data and the tools that we make available through Argus are providing those insights to understand kind of the impacts in the past and model future conditions, and what assumptions do you have to make about the number of satellites that are launched up into orbit until you start to kind of create certain challenges like the one that you just highlighted.
Yeah, I could maybe make one comment about it. Obviously, there's been a lot of discussion about the SpaceX Starlink constellation and the impacts of that on the night sky. You may be aware that SpaceX has redesigned the satellites now so that they don't reflect in the terminator condition. And so there are things that can be done to the satellites so that you don't get that reflection of the sun, right as it's going down over the horizon, reflecting off the satellite, really disturbing the night sky. So I do think it is something that we're going to have to look at we as a human community in the next couple decades, if we really are going to launch 20,000 plus more satellites to serve all these communication needs and all the other things around the planet. It is something that I think needs to be looked at, but I think there probably are, in most cases, some technical solutions that really help.
And with that, we'll close things out. Thank you, everyone.
Thank you.